This was a real-time clock card at the end of the last video. What we've added is the CR2032 battery. These are not supplied with the card, but they are easy to come by. I've also added the two jumpers to give us the correct address for our Z180 computer, which is here. All we have to do now is to plug this in. And that is the card added to our system. Next we will power it up and we have a look to see how the card behaves. Here we are now inside TerraTerm, the application we use on a computer to talk to our Z180 system. If we hit the reset button on the Z180 card, our computer has now booted up. I have already set the date and time on this computer, which you can see at the top of the screen. However, I'll step through the process just to let you know how it's done. First of all, we're going to go into CPM. Once in CPM, we're going to run a program called RTC. This displays the commands we can actually use in RTC. First of all, we're going to initialize the clock. So we'll press the letter I, and it will prompt us for the year. It's wanting a 2-character year here, so we'll put 24. The month, 03, and the date, 10. The current hours, minutes, and seconds. The day it wants is a number between 1 and 7. 1 for Sunday and 7 for Saturday. So we'll put in 1. Having entered that, the next thing we have to do is to use this set command. This will set the time on the clock. So we'll press the letter S. Now we can see the time by pressing the T button. It shows us the current time and the current date. You can use the other options to make sure that the time clock is in fact advancing. So if we press the L button for loop, it will show us the time, and each time we press the space bar, it will show us the current time. So we can quite easily see that the time is indeed advancing. So now that we've got the time set on our computer, our RTC clock is running, what can we actually use it for? Well, if we hit the reset button once more, the version of CPM we're using is version 2.2, as you can see here on the screen. So as CPM 2.2 is not particularly date or time aware, we're going to use the ZS-DOS system. So if we press Z, and that says now in ZS-DOS. If we do a quick directory on the A drive, there are no files on the A drive at the moment. So we're going to create a file. But before we do that, we'll set ZDOS up so that it can accept dates and times. Our first task is to load the resident time driver. We can do that by typing LDDS. And that's the driver loaded. Then we can run PUTDS. It will specify which drive we want to do it on, so we're doing that on the A drive, which is our RAM disk. And it's going to create a file called time.dat, and we'll mark this as a system file. And that says completed that. And we will do a relog, and also an init dir. Right, we are now ready. Now, as we said, if we do a directory on the A drive, there are no files currently sitting in that RAM disk. So our first task is to create a file. We can do that by using the editor. ed for editor, and then the A drive plus the name of the file we wish to create. We're now inside the editor. So if we press the letter I, so we can do an input. This is some text. And once we've finished typing, we can close that off by doing a Ctrl Z. And then the letter E to save our file. And if we do a dirt on the A drive, we can see we have two files. We have the original text.bat, which was when the file was created, and text.txt, which is the current file with the data we typed in. So how can we see the dates? Well, we can use the file date command. You can abbreviate this as FD. So we do it to show all the files on the A drive. And this is showing us the creation times, the access times, and the modified times. Since there's no date showing, it's showing as today's date. And today's date is showing on the screen. So we now have a Z180 system which is time and date aware. So any files we create will be shown with creation dates and when they were last accessed and when they were last modified, as well as the size. So we can see, in summary, our real-time clock card is working perfectly well. As the A drive is a RAM disk, this data will disappear as soon as we power the machine off. So the next logical step is to add some permanent storage to our computer. However, that will be in the next video. That's it for today. Thank you for watching.